All right, here's a quick video going over 1.6 part 2 homework questions. So we're down here in 1.6. By the time you see this, there'll be a bunch of links to videos for 1.6 part 2, just like there are for 1.6 part 1. I'll also post my notes from this section in here. We already have a video for homework 1.6 part 1. Now I'm making one for 1.6 part 2. So when you go in there, you'll see kind of a weird assignment, and that's because we're limited by what we can do. Like really from this section, I want you to be able to make a histogram. But it's kind of hard for you to make a histogram on an online homework system. So what these questions tend to be about histograms is more understanding what they tell you, kind of. I don't even know if they're good problems. I don't know if they're worth your time, but they're probably things you can do in like 5 or 10 seconds. So maybe you can fly through some of these really quickly. This first one just says, if you had this data, it doesn't even give you the data. It already puts it into different groups for you. I feel like at a minimum, it should give you the data and let you put it into groups, but fine, it doesn't even do that. It says you got two observations that are between 2 and 7. Note this notation is called interval notation. It means greater than or equal to 2, but strictly less than 7, which is kind of the way we've been doing these. There should be 2 observations in that group, and 3 in this group, and 7 in this group. And you just look at these and are like, which one of these corresponds to that? Multiple choice, you answer it and you move on. I don't know. Second question. This one a little bit better, I guess. Again, they give you a histogram as opposed to having you make a histogram. But then they ask you which statement below best describes the meaning of the second bin in my version of this. So the second bin is this one right here, right? It's the one that goes from 202 to 204 and it has a height of 2. And you're supposed to figure out, does that mean that there are 202 snacks that contain 2 milligrams of sugar? It doesn't. Well, what about this? What about this? What about this? Read these statements. They're all kind of involving 2s and 202s and 204s, and maybe you can figure out what that means if the height of this bar is exactly 2. Third question. I kind of like this one. They made you a histogram, and you're supposed to pick which type it is. Is it uniform, bell-shaped, skewed left, skewed right? If I were looking at this, I would call this one skewed right, because most of my observations are over here on the left, but I have this tail going down to the right. Let's see, I'll get it wrong so I can do it again. I think if I reattempt, yeah, they give me a new picture here. All right, and this new picture, if I had to look at this one, I'd call it bell-shaped. You might argue that it's not perfectly bell-shaped, it's not exactly symmetric, but it looks pretty damn close. I think that they're looking for bell-shaped on this one. Can I keep doing? Yeah, let me keep doing it. What about this one? Right, all the bars are more or less the same height, so that's what we refer to as uniform distribution. Keep doing theirs. Here's one where they give you. Maybe you can look at this and tell that this would be skewed left. Hopefully all the examples that you get when it randomly generates these graphs for you are as obvious as the ones that I'm seeing here. That, oh yeah, that's definitely left skewed. It's not, oh, it kind of looks sort of bell-shaped, but it's also kind of skewed left or skewed right. If you get one of those, just guess, submit. If you get it wrong, try it again. As long as you get it right the first couple times, you're good. When I put something like this on a quiz, I'll try to pick pretty extreme examples. So something like this, if I want something that's skewed left. Tail going out to the left here. Fourth one. This is the last one to deal with histograms. I guess it's getting into some vocabulary words. You're looking at this histogram and you're supposed to figure out the class width. This is the length of the bins. So this is what you would put in for X scale into the window column on your calculator. So maybe by telling you that, that's enough for you to figure out what somebody put in for X scale into the window value of their calculator to get this histogram right here. And then what is the sample size? It doesn't explicitly tell you here. How many observations did the person have when they made this thing? But maybe you can be kind of clever and figure out how you could deduce that from this picture. So without telling you the answers, that's what they're asking you for here. Question number 5. I really like this one. I think this is the best one on the homework. They give you a box plot. It would be a little bit better if you had to make your own box plot, but what are you going to do? They give you this box plot, and then they give you 3 statements, and you're supposed to figure out if these statements are correct or incorrect. And I think you could figure out all these things from the box plot, although it's not always obvious. They say that this is skewed right. Maybe you agree, maybe you disagree. They tell you the interquartile range. So that's really tricky. It doesn't explicitly tell you the interquartile range, but based on this box plot and things that you know from this box plot, I think you can calculate the interquartile range and see if you think that it's about 8. And if you agree, great. If you disagree, that's fine too. And then the median. I think you can get the median straight off this box plot. And so figure out which of these statements are true and then answer which ones are true down here. It's a good question. Expect to see that kind of stuff on quizzes and tests and stuff. Question 6. All right, this is another it's doing its best. I didn't want to find a problem where you completely make a stem and leaf plot all on your own. But here's one with kind of that idea. You have a whole bunch of data here. It'd be a lot of work for you to change all these observations. What are there, 30 of them into a stem and leaf plot. So a lot of it's already done for you. So when the stem is 4, here's all the leaves. When the stem is 5, here's all the leaves. When the stem is 6, here's all the leaves. These little pound signs here, we don't put those in our stem and leaf plots, just ignore them. When the stem is 7, you're supposed to input the leaves. So go searching through here. If you get it wrong, it's probably just because you missed an observation that might come from a 7. Make sure you can find all the observations that come from 7, put their respective leaves in here to finish up this stem and leaf plot, and that's all you're doing for question 6. Question 7, again, with the stem and leaf plots. On your quiz this week, I give you something a lot like this for what it's worth. I don't ask you to make a stem and leaf plot on your quiz. I give you a stem and leaf plot. And then I say, all right, now that you have this information, now that you have this data, do something. So one of the things you could do, this isn't what I ask you to do on the quiz, but one of the things you could do is give a 5-number summary. Sure. Right? If you have the data, you can do any question that involves data. And when you're given a stem and leaf plot, you're essentially given the data. One problem with this problem that I have is really it should have a legend, right? You don't know that this leaf of 1 that is on the row with a stem of 3 represents a 31. It could represent a 3.1. This really should have a legend which says 3-1 means 31 so that the reader understands that this 1 corresponds with an observation of 31 as opposed to 3.1. I can tell you, because I've done this problem before, that they mean 31 here. But really it should have a legend. When I give you this on your quiz this week, I will say, oh, by the way, 3-1 means 31 when I give you this. Anyways, you get the data from here, you put it into your calculator, you go to one variable statistic, you can figure out the minimum, Q1, the median, Q3, and the maximum. Suppose you can get that off of a box plot as well, if you want to get it that way. This has nothing to do with outliers at all. It's just the smallest observation, the largest observation, first and third quartile, and the median. Last question here, probably the hardest one. This gets into shape, but rather than having you figure out the shape from a histogram or from a box plot, which is a little bit easier, you're supposed to figure out the shape just by a description of the situation. And in my opinion, that's the hardest one to do. My hint on these is try to draw box plots. All right, so maybe we'll do this first one together. You read through this one, and all you're supposed to figure out is what shape does it have? Is it left skewed, right skewed, or symmetric? And I say those 3 choices. They don't even give you uniform as a choice. And then once you figure that out, you can determine whether the best measure of center is a mean or a median, and whether the best measure of spread is IQR or standard deviation. And you do that several times. I think there's 4 of these that you do those exact same things for. So let's do part A together here. Housing prices in a country where 25% of the houses cost below 350 grand. What that is telling you is that your first quartile is 350 grand. Because your first quartile is the point that separates the bottom 25% of observations from the remaining 75%. So when they say that 25% of houses cost below 350 grand, you know that if you were making a box plot, like you can make an x-axis here, that the left edge of your box should be at 350 grand. 50% of the houses cost less than 450 grand. That sounds like a median right there. 75% of houses cost less than $1 million. There's my third quartile. So from those first 3 phrases, I could make the whole box in my box plot. At the left edge of the box, the line going down the middle of my box, and the right edge of my box. And that might be enough to tell whether it's left skewed, right skewed, or symmetric, but then they give you a little bit more information. There are a meaningful number of houses that cost more than $6 million. Damn, must be nice. All right, so you're picturing a big, long whisker going out to the right. You're picturing a box plot whose left edge point, the left edge of the box is at 350. The right edge of the box is at $1 million. And the line going down the middle of the box is at 450, much closer to Q1 than it is to Q3. And furthermore, you have this big, long whisker going out to the right because you got these crazy expensive houses. You can't have a big, long whisker going out to the left because you're not going to have a house worth less than 0. So although it doesn't explicitly tell you anything about the whisker to the left, you know it can't be that long. But there's a big, long whisker going out to the right, maybe even some outliers out here. It definitely sounds like a right skewed distribution. Most of the observations are on the left, big, long tail to the right. And as we learned in the video, and if I'm being honest with you here, I forgot to put this into the video, but I'm about to add it right now. Anytime your data is skewed, we're worried about outliers. And anytime you're worried about outliers, the median and the interquartile range are the measures that you use for center and spread. And that makes sense because the median and the IQR are the 2 that are resistant to outliers. Right? So if your data is skewed, you're worried about outliers. If you're worried about outliers, use measures that are resistant to outliers. Quote the median and the IQR. If you had decided that this was symmetric, to be clear, it's not symmetric, but if you decided that, then you would have used the mean and the standard deviation as your measures of center and spread. Because anytime the data is symmetric, we're not worried about outliers. And if we're not worried about outliers, we don't need the measures that are resistant to outliers. But to be clear, the answer for the question the way it's written would be these three right here. And if that makes sense, maybe you can go through and do something similar for B, and then C, and then D, and then you are done with this homework.